Thank you so much, Daniel. So before we get started, I'd like you to do me a favor. Would you take out your phones, open up iMessage or WhatsApp or whatever messaging platform you use, and send a message to the two most important people to you and tell them how much you care. Let's just do that quickly. I did it before I came up on stage. And I'll wait. See, the truth is, we don't usually take enough time to tell the people we care about how much we care. Sometimes we get wrapped up in conferences and just life, and we just don't take the time. So I'd like you to take the time now. So hopefully you've had a chance to tell people you care, and I'm going to get started. So as Daniel mentioned, this summer I had an opportunity to make an enormous change in my life. I joined a great company called Wealthfront. They build an automated investment product. Investments is something I know nothing about, which is one of the reasons why I joined them, because I want to make investments something that people can do without knowing anything about investment. But one of the things that attracted me to them is they do a lot of unit testing and a lot of automated testing. And previous to this, I really didn't do any testing, which I'm kind of ashamed of. But before joining Wealthfront, this was my most prized form of identification. In 2011, I joined Apple, and I became a member of the Game Center team. Many of you have probably used games that run on the GameKit platform. And I built parts of the Game Center app and features in the GameKit framework. Nothing really important, nothing really groundbreaking, nothing really interesting. But it was a foundational time for me until about 2013, when, for family reasons, I moved up to Seattle and I went to work on the iTunes organization and began working on iTunes Connect for iOS. Now, this is an app many of you love to hate. Oh God, iTunes Connect for iOS, man. It was a one-star app. The entire time I worked. No, that's actually not true. It made it up to about 2 stars. Yeah, it was pretty amazing. It was a little demoralizing. But it was really amazing, because when I started, it was a code base that had begun with the iOS 2 SDK. And as many of you know, that was a long time ago. And like 2008. And the code really showed it. So did the UI. And it was partly my job to completely renovate that application. And as part of that renovation, I had the opportunity to give a talk at DubDub in 2014. And that talk was all about how we had brought a brand new UI to iTunes Connect for iOS, all built on collection views and these rich data sources, and it was really exciting. Now, one of the great things about giving DubDub talks, especially when you're on stage in front of a terrifyingly large audience, is that people come up to you for years later and tell you how much they like that talk. And interestingly enough, they tell you how that talk influenced their application, and how the sample code that you released became a part of their application. And that kind of frankly terrified me, because I was discovering bugs in this code that I had released, and I was unable to fix them. Because Apple is really, really great at providing forward-looking statements. They're always telling you, here's the latest technology, here's the newest thing you can do. But they're not so good at providing retrospectives. They almost never go back and say, you know that thing we told you to do? Self-sizing cells? That was a terrible idea. And so I never really got the chance to correct the sample code, implement some of the features that I sort of promised on stage that I would. It was unfortunate. So here I am today. And I get to do a lot of these things, although I'm never going to fix that sample code. Oops. So I want to recap a little bit of the architecture that I talked about in 2014 so that some of this has a prayer of making sense. Remember, we're talking about collection views, so we're talking about data sources, we're talking about fetching information from a back-end server. And this is how our data sources were architected. I am a huge fan of state machines, and if you're not, you're a terrible person. So we have our state machine over here. It starts off in this idle initial state, and it very quickly moves into the loading content state where it makes a request of the server. Now, our data sources are smart. They load their own data. And so in all of my sample code, I use big cats as the example because I am a cat fanatic. What Daniel didn't tell you is I have 5 cats at home. When I get home, I'm going to have to pry my girlfriend away from one of my cats because he has claimed her as his own. So ideally, everything will go well. And the server will respond, hooray, your data is good, and you can progress on. And we'll transition into the content loaded state, display the cells, and everything will be great. However, that doesn't always work. Sometimes the server returns no content, either an empty list or a special error code, and we transition into the no content state. In less frequent cases, we hope, the server returns an error, and we transition into the error state. The way this looks in the UI is in the loading content state, the collection view displays a supplementary view with a UI activity indicator view. This is literally the sample code from 2014, recompiled in iOS 13, and so it doesn't really work very well. I'm pretty sure I didn't account for safe area insets, which didn't exist back then, which is why the spinner's way down there. Plus it has bugs. I don't know who wrote this crappy code. So when you transition into the content loaded state, all the cells pop in, nicely animated, hopefully. However, when the server responds with no content, we display a supplementary view that displays a placeholder object where the content of the placeholder is under the control of the developer. And in the hopefully unlikely scenario that you have an error, we will similarly display a placeholder view in a supplementary view. So that's all great. It's not terribly interesting because it's just a data source that has a state machine in it, and that's not very much, right? Where it got interesting was when we did something called an aggregate data source. That allowed us to build data sources that had much more complex structures. We really only had 2 aggregate data sources that were really very interesting. The first was a segmented data source, and that allowed us to have multiple data sources that we would switch between with a UI segmented control. And that segmented control would appear either in a header, like a supplementary view, or if that segmented data source was the root data source, we'd elevate that into the title view of like a navigation bar. The other aggregate data source that we had was a composite data source, which, as you might imagine, would have each of its child data sources as a section within itself. And that could get kind of complex because you could have a composite data source, which had a composite data source that had children inside of it. And this got a little hard to maintain sometimes. But fortunately, none of my colleagues wanted to work on it, so I got to do it. What this wound up being was a tree of data sources. And as each of these data sources would start out, they'd start out in the initial state, then they'd all transition to the content loading state and make their network requests. Well, as we heard earlier, you have to be really careful about making sure you update your collection view all at once, right? Otherwise you get that dreaded internal exception. So when one of these data sources would get its data back, we couldn't necessarily update the collection view because the data source wasn't in a known good state. So we had to wait until the other data source, or really all the data sources, were complete. So the way we did that is we would have a completion block that we would pass up the tree of data sources until it reached the root. And then finally you'd have the other data sources would complete, they would pass up their completion blocks, and finally everything would be done. And then we could call perform batch updates, execute all of those completion blocks, and ideally, nothing bad would happen. But I can tell you, after 8 years at Apple, I still couldn't make this work 100% of the time. I had to have workarounds sometimes. I had to patch things. I had to occasionally, do the UI view, perform without animation, just so that I can ensure that this would work. Now, if I had the diffable data source, I'm absolutely certain that I could have done this perfectly. But I didn't, right? We didn't have this until just this year. So most of the time it worked. And the rare times that it didn't, there were known workarounds. And we shipped release after release. Hooray. Still 1 star, but it worked. But all good-ish things come to an end. In 2018, iTunes Connect for iOS was end-of-lifed. No one really cried, not least of all me. It was replaced with App Store Connect for iOS, which was much better. Mostly, it was a rebranding. But under the covers, what you all didn't see was that I got to rip out a tremendous amount of code because iTunes Connect for iOS supported lots of content types: books, movies, ringtones in 2018, and other things. And all of those things required me to keep maintaining them, occasionally implement features, all for people who never, ever signed in. I mean, statistically speaking, never signed into the application. So by ripping all that code out, I was able to focus all of my efforts on building features for the people who actually use the application, you all. And App Store Connect for iOS also came with a slightly new UI, represented here by a updated sample application, which is entirely fictitious, made in Slack. Not Slack, what's it called? Sketch. So you'll notice we have all our big cats is favorites and all cats, all in one nice list, so you can find everything right in one place. On the iPad, we use a UI split view controller so that everything's right there for you. It's more compact, more easy to use. Now, one of the important design constraints was that whatever was the first item in the list, whether it be a favorite or a all thing, be displayed as a detail item on the iPad. We figured because it's the most frequently updated item, that's probably the one you wanted to interact with most. Now, on the iPad, when you're in portrait mode, we make the list of items slide away because most likely when you come in, you want to interact with the app that's changed most recently. And if not, you could pick a new one. Well, as I was developing this, I ran into at least one interesting bug. And that was when you would start the app in portrait mode on iPad, you'd get this weird placeholder. And it didn't take me that long to figure it out. But it turns out that UI split view controller, if the main view controller isn't visible, it doesn't even load it. Never called view did load or any of that stuff. And our data sources were tied to that whole loading process of the view controller. So since the data source load the list of applications, or big cats, the app had no idea what its content was. That was kind of a problem for an app that's all about manipulating the list of apps or big cats, right? And that kind of got me thinking that maybe I was doing something wrong. And I could think of ways around this, right? I could poke UI split view controller and say, no, really, load your main view controller. Or I could poke the data source and say, no, load your content. But both of those things felt like I was subverting those architectures. The way I ultimately got around it is even worse. I copied the code out of the data source that load the content, and I pasted it into the overarching view controller. And that felt kind of sickening, right? I'm duplicating code. But it felt a little bit better than subverting the architectures that I had. But it really got me thinking that something was wrong here. And I took some time to review the four most important parts of this architecture that I had built. And the first one was that I wanted to reduce view controller complexity. And we really had done a great job of that, right? Our view controllers only handled the most important things that they needed to do. Button presses, presenting activity sheets, that kind of thing. Mostly because we relied on the responder chain and things like of that sort, so that the view controllers only did exactly what they needed to. The second thing was that we wanted to promote code reuse. We figured that by putting things into the data sources, we could have data sources that we could use throughout the application. And it turns out that didn't really work so well, because we wound up with data sources that were highly specialized for the area of the application they were in, as exemplified by the fact that I couldn't use this data source to get the list of applications. And secondly, we wanted to isolate task-specific logic. Or thirdly, sorry. And at first glance, it looked like we had done a great job of that, right? Because the data sources loaded their own content, the view controllers dealt with user interaction, the networking layer handled all interaction with our server. But as this bug indicated, maybe we had done too good a job of isolating task-specific logic, right? Because I couldn't get at the loading code when I needed to, and I couldn't get at it in a way that was sensible for a different part of the application. And finally, number 4, which was personally most important to me, I wanted a unified loading indicator. I wanted users of the application to be assured that when the loading indicator was done, all the content was ready for them. And yeah, we nailed that, but it came at an extreme cost. The data source architecture was really, really complex. I'm talking thousands of lines of code. And that's kind of ridiculous in hindsight. When I think that I was on stage promoting this, that's kind of embarrassing. So that led me to think oh shit, I was wrong. Perhaps I built the wrong architecture for this entire application, right? I mean, a score of 2 right out of 4 is really not very good. If I were being graded on that, that would be a failing grade. And to all of you who may have used that architecture in your applications, I'm really sorry. Maybe you should be a little bit more skeptical about what someone on stage is telling you. Seriously. So the thing is, though, as Miles Davis says, there really are no errors. So don't be afraid of making mistakes. So the thing that you have to keep in mind is, as software engineers, as software leaders, our job is not to write code. Our job is to make decisions. We make decisions about what lines of code to write, about what algorithm to choose, about what data structure to use. And we make these decisions based on the information that we have at the time. So if the information changes, you can't necessarily consider the fact that you've made an error. You just have new information. And maybe then you need to reevaluate your decisions. So, with that in mind, I took advantage of the fact that I know people who are way smarter than me. Well, nearly everybody, really. But I reached out to a good friend of mine, Dave DeLong, who has a great talk on the MVC side of things. And he also is responsible for one of my favorite, all-time favorite dub talks on advanced operations. If you haven't seen it, you should probably go look it up. And I talked to Dave about maybe merging these two things together, the idea of view controller containment with the idea of using the advanced operation technique and somehow coming together with a blend of that. And what we came up with was what I call an operation view controller. And you'll notice it also uses a state machine, because I'm kind of nuts about state machines. It's a little slightly easier to understand state machine. There's one less state in it. It starts off in an initial state as well. And the operation view, let's not jump ahead of ourselves. The operation view controller has a content operation. And we'll talk about where that comes from in a moment, but it observes the isFinished state of its content operation. Now, one of the whole goals of the operation view controller is I really wanted to use really standard COCO paradigms, things that everyone in this audience would know. Nearly every COCO programmer would know. So when the isFinished property is false, then the operation view controller is in the waiting state. As long as it's false, it's in the waiting state. Okay? When that changes to true, then we check whether or not the content operation conforms to the error reporting protocol. And if it conforms to the error reporting protocol, we check whether its number of errors is greater than 0. And in that case, we either transition to the error state or the no content state. Or I guess maybe it's empty state in this case. Because it turns out that empty is just a special form of error. It's the no content error. And maybe there's a better way to do that, but it worked out just fine for us. However, hello? If it doesn't conform to error reporting, or it has no errors, then we'll transition to the complete state. Pretty simple, right? A little bit of KVO, a little bit of properties, a little bit of protocol conformance, you're done. And the way this looks from a UI standpoint is in the initial state, you're not showing anything. There's no contained view controllers. But when you go into the waiting state, the operation view controller will display its activity indicator controller, activity view controller, which if you do nothing is provided by the little frameworky thing. It's completely customizable. If you want to provide a view controller that's bright green and has dancing unicorns, go to it. I wouldn't advise that, but you could do that just fine. By default, you get a view controller that has a UI activity indicator in the middle. When you transition to the error or empty state, you get a nice little, oh, sorry, getting ahead of myself. Wait a minute. I didn't get it. Sorry. This clicker's getting low on batteries, I think. When you get in the error or empty state, you get a placeholder view controller that, again, is provided by the framework. And that has a view controller with a placeholder object where the content is provided by the user through a little bit of protocol conformance magic. And then finally, the moment you all saw earlier, when you get to the complete state, this is the only thing that the developer actually has to provide, which is the content view controller, which in our case is a table view showing big cats. All really simple stuff and very easy to implement. So the way the operation view controller actually gets its content operation is, again, super simple Cocoa paradigms. It asks its delegate, it says, dude, give me a content operation. And it receives an NS operation in reply. But we didn't want the operation view controller to be responsible for too much, right? Because it's not really a great idea to overload any one class. So rather than have the operation view controller maybe have an operation queue or ask its delegate to schedule the thing because maybe its delegate's not ready to do the scheduling. What we figured we'd do is we'd have the operation view controller call add operation on itself. And we take advantage of the responder chain by implementing add operation on NS responder. So that just bubbles up the responder chain, doesn't get found on the big cat view controller, which is the composing view controller, but we do find it on our app delegate. So app delegate overrides add operation just to add it to a queue. Now in real life, you might have multiple queues for different parts of your application. That isn't as crazy as you may think it is. In App Store Connect, we actually had 4 queues that had multiple different reasons for existing. Some of them good, some of them legacy. So let's take a look at some of the advantages of this architecture. Number one, oh look, it too reduces view controller complexity. I wouldn't have maybe come up with something that didn't, right? That would seem like a bad idea. Number two, it does, right? It does look a little bit easier to maintain. It's actually a lot easier to maintain. There's maybe a couple hundred lines of code by comparison to the, oh God, thousands of lines of code. And when shown to one of my colleagues, he was actually willing to work on this code, as opposed to horrified by my collection view code. So number three is it actually promotes code reuse, because what you're left with are a bunch of little NS operations running around your code that you can actually use elsewhere. So when I wanted to load the list of applications, I had a little NS operation to do that. And I could use that elsewhere in the application to say, hey, fetch me my my applications. When I wanted to sort the search results, that was an operation. I could actually use sorting later. And then number 4, my personal favorite, yes, we still have a unified loading indicator. Now, in truth, I've moved some of the responsibility from making sure that everything happens all at once onto the developer, right? Because it's the developer's responsibility to ensure that one operation is responsible for loading all of their content. Maybe that's not so great, but what I found in a lot of the data sources is I was managing a lot of dispatch groups because I was making a bunch of different network requests all within one data source. So I was having to do a lot of that anyway. So by moving it into NS operations, I can take advantage of the dependency management, and I get that for free. So now what? I've got a great new architecture, or at least my latest great new architecture. What do I do with it? Now, the thing that you may all be thinking is easy. You just refactor your app. Now, you and I may be thinking of refactoring as this precision operation where you take every little piece apart, you know exactly where it is while your app's torn apart, and when you're done, you just put it all together and it'll work perfectly the first time, won't it? Well, when I say refactor to my boss, this is what he hears. I'm going to tear it all down, I'm going to burn it all to the ground, and it's not going to work for 3 to 6 months. And at the end of that, there's going to be a mysterious unknown number of bugs that will linger for anywhere from 6 months to a year. I would love to say he was wrong, but he's not. Because in truth, the multiple times that I have refactored things on either iTunes Connect or App Store Connect, that's largely been the outcome because there were no tests. There was no anything. So it's really hard to know that like you've actually made it work. So what do? Right? You have to have a plan. And as Bono would say, right? I'm going to actually try and read this. Idealism detached from action is just a dream. But idealism, actually I'm going to read it from my own screen, allied with pragmatism, with rolling up your sleeves and making the world bend a bit is very exciting. It's very real and it's very strong, right? You have to blend the idealism of a brand new architecture with the pragmatism of getting there over time with a plan to get there. Because I knew if I went to my boss and I just said, I've got a great new architecture, let's just burn it all down and start again, I would never get there. So, the plan I came up with, you're not going to be surprised to hear that it also had 4 points. The first one was let's get that operation infrastructure in place. We were already using NS operations. They were sort of hidden in our networking layer. So we already had a queue or 2 in place. So we exposed that to the rest of the application. We made that a first-class citizen of the app, and we made it possible for other parts of the application to start scheduling operations. The second thing was put the operation view controller in place so that newer parts of the application could actually start using this functionality. Number 3, I got to fix that original triggering bug. See, I had fixed it, but not in a way that I was proud of. In fact, every day I would open up the code, I would just sort of hate myself a little bit more because I knew that I had done a terrible, terrible thing. But now I had the opportunity to go back and fix it in a way that frankly didn't suck. And then finally, number 4, refactor the existing code, but only in small bits, only as needed and as I touch those screens and as I touch those parts. So this took me 5 releases to do. We started before we actually released App Store Connect. And the release schedule was, every 3 to 4 months. So this was more than a year and a half to go from almost all collection views to, there's a few of them still left, but it's mostly all table views or other things at this point. But it's mostly all using this newer architecture. I didn't quite get done because I left. And that's the thing that does happen. Sometimes you don't finish on your plan, but you make your best effort. So I want to leave you with one last thought. As Marcus Miller says, I'm going to have to read it off my laptop because I'm not wearing my glasses, so I can't see. It's a great thing about being a musician. You don't stop until the day you die. You can improve. So it's a wonderful thing to do. And I think this is also true about being an engineer, right? You've heard today about how it's important to always keep learning something new and about always stretching and always growing. And that's so tremendously true. Don't look at a setback as just the end of the world. Don't look at it as a failure. Look at it as an opportunity to try something new, to grow a little bit. So thanks so much. It's been wonderful talking to you. And if you want to get in touch, you can find me on Twitter or email.